Good evening, everybody. Welcome to the review for test number 1 of Chem 170, fall 2023. Well, where's this century gone? Anyways, all right. First of all, hopefully you've done the review, watched the videos and done the practice problems. Now, the file I'm showing, these slides are from the lecture folder in D2L, and it's cleverly named Test 1 Review. And you can download it and look at it anytime you want. All right, let's get going. First of all, you should know what a hydrocarbon is. And a hydrocarbon is a molecule with only carbon, hydrogen atoms. Now, there are two types of hydrocarbons you should know. Hint, one is a saturated hydrocarbon, and that's molecules with only carbon, hydrogen atoms, which all carbon-carbon, this is important, carbon-carbon bonds are single bonds. And the other type of hydrocarbon are unsaturated hydrocarbons. Those are molecules with only carbon, hydrogen atoms, it's a hydrocarbon, that contains one or more carbon-carbon double or triple bonds, multiple bonds. Now, I'm not going to ask you, but I put it down. What are alkanes? Acyclic saturated hydrocarbon. Acyclic means without a ring. And this, a mistake. And cycloalkanes are cyclic saturated hydrocarbons. Sorry about that. Now, one of the most important things, if you watched the video, you saw me doing this a lot, and that's how many bonds to carbon. Oh, I gotta get this finger fixed. How many bonds to carbon? 4. So you should always remember there's 4 bonds to carbon. Now, I started teaching about the nomenclature rules, which IUPAC, and I'll never ask you what does IUPAC stand for, but that's the International Union of Pure Applied Chemistry, the organization located in Geneva, Switzerland. And the first thing, which if you did practice problem number 1, identify the longest chain. The carbons connect together. Ooh, let's try one. All right, I'm not going to even put in the hydrogens. Time for you to have some fun. How many carbons are in the longest chain in what I just drew? Your turn. I'm going to make it worth your while that you came here tonight. While you're doing that, I'm going to have some water. And I don't have it set up for this meeting, but give me a thumbs up either on your, if you have your cameras on, or use the emoji. When you're done, give me a thumbs up. Everybody done? Okay, let's get going. All right, I can count across 1, 2, 3, 4, 5, 6. That's one chain. Now there's another chain. 1, 2, 3, 4, 5, 6, 7. And there are other chains too, like 1, 2, 3. Down here would be 4. This would be 5, 6, 1, 2, 3, 4. So the longest chain is this one. 7. So if I were to ask what's the longest chain, and you need to know how to do that to do IUPAC nomenclature. Now, you should know the alkane names 1 through 10, methane 1, butane 4, hexane 6, decane 10, octane 8. Where have I heard that octane? Oh, gas station. Remember, they're alkanes, saturated hydrocarbons, and gasoline, alkanes. And then I talked about the alkyl groups. And here you should know CH3 attached to something is a methyl group. CH3, CH2, where it's at the end carbon, is an ethyl group. There are 2 3-carbon groups. When it's to the end carbon of 3 carbons, that's N-propyl. When it's to the center carbon of 3 carbons, that's isopropyl. And there are actually 3 butyl groups, but one in the last, I hate to say this, oh my God, 50 years of me doing organic chemistry. Wait, I shouldn't have said that. I feel old. But anyways, I've never countered a sec-butyl, which is why I'm not teaching it to you. But if you have 4 carbons and the N carbon is bonded to something, that's N-butyl. And my favorite, along with isopropyl, I like them all, but I love T-butyl group. When we get into alcohols, you'll find out, I think it's alcohols, you'll find out one of the reasons I like T-butyl group. Also, in my PhD thesis work, I used isopropyl and T-butyl groups. Now, hopefully you've watched the videos. That's not what I want. And don't forget, there's 4 bonds to carbon, which I know now, so I can put in the right hydrogens. And the question would be, give the IUPAC name for the following. Your turn. I'm going to let you have some fun too. And for those of you who turned on your webcam, thank you. And for those of you who showed up and didn't turn on your webcam, thank you for showing up. Because you get to experience Dr. White live in person. Hopefully that's a good thing. And when you're done, give me a thumbs up. If you finish early, let's give everybody time to finish. Okay, looks like everybody's finished. First of all, you got to find the longest chain. I'll start here, 1, 2, 3. Then this would be 4, 5. That's one chain. 3, 4, 5. This would be 6. That's another chain. What if I have 5, 6, 7, 8? 8's the longest chain. And you should know that when you have 8 carbons Hi there, Galilea. Did I pronounce your name right?
Yes, it's Galilea. So like Galileo, but with an A.
Galilea, say it again.
Galilea.
Galilea.
Hmm.
Okay. One thing, I've never learned how to roll my R's, so luckily you don't have one in your name that I have to roll. All right. Longest chain, 8 carbons. You should know that's octane. That's the base name. As soon as I say octane, all this, hold on, all that's spoken for. And we have 2 alkyl groups. Here on carbon 3 is an ethyl group, on carbon 5 is a methyl group. And I'm not holding you to the alphabetical order, but I UPAC and I hold myself to it. This would be 3-ethyl, 5-methyl octane. Now, if I counted from the other side, 1, 2, 3, 4, 5, 6, 7, 8. Notice here the methyl is on 4, the ethyl is on 6, the other way 3 and 5, and you always count from the side that has the lowest numbers. Also, you always start from the ends. Common mistake students make, they'll call this 1. No, it can't be 1. The ends have to be starting with 1. So that's how you get an IUPAC name. And as I mentioned, I think I did, there are 2 types of nomenclature problems. One is give the IUPAC name. The other is let me undo this. The other type of nomenclature question is draw the structure for the following molecule. And I'll do that. How do you do that? You always start from the right, move left. Hexane, 6 carbons. Cyclohexane, 6 carbons in a ring. And if your rings don't look as pretty as mine, I've been doing it a few more months than you have, a few more months. And a T-butyl group, since there's only one substituent, you can put it on any carbon on the ring. Most of you are going to put it on the top, so I won't disappoint you. And now you put in the hydrogens because there's 4 bonds to carbon. And that's T-butyl cyclohexane. Don't forget, everything you're seeing tonight will be on a video later tonight. I'll post it in my YouTube channel so you can come back and watch it. All right, now, one of the things I've done in this class, I'm spelling error. Did I tell you I was the first one down in spelling bee and probably still would be? All right, you should know some real world uses of molecules we'll use in this semester. And for alkanes, where you'll find it, natural gas, that's methane, the propane for your barbecue, gasoline, Vaseline, baby oil, candles, they all have alkanes. Now, the only reaction I asked you to learn for this first chapter are alkanes and cycloalkanes. So you take an alkane or cycloalkane, react with oxygen, you get CO2 and water. You also get heat. In this class, remember, you do not have to balance any equations. I'm just looking for the structures of the products. So let's have some fun. And the question would be, what are the products, there are two of them, of that reaction? Your turn. I'm going to let you have some fun too. Am I nice or not? Sharing all the fun. Now, hopefully what I'm doing now is not new to you because you've watched the videos and you've done the practice problems. And when you're done, give me a thumbs up. If your camera's on, just go like this. All right. And I think everybody's done. So how do you do this reaction? Well, what do we have here? An alkane. Carbon, hydrogen atoms, carbon-carbon single bonds, and we have oxygen. And you've learned this general reaction gives carbon dioxide plus water. And the answer here is carbon dioxide and water. And that's how you do it. And let's move on. Don't forget, there's no such thing as a dumb question. Always feel free to ask questions anytime you're with me. Now, one of the things, sometimes if you do it through the chat, I might not be looking down at the bar because it goes away, but turn on your microphone. Always feel free to ask questions. All right, next I talked about alkenes and alkynes. An alkene is a carbon-carbon double bond shown by carbon with two lines. An alkyne, carbon-carbon triple bond. And you should know an alkene has one pi bond and one sigma bond. Alkyne, a triple bond, has two pi bonds and one sigma bond. I like the special effects. Don't answer that. But anyways, also remember each bond here, each line represents two electrons. So in a double bond, there are actually two pair, 4 electrons, triple bond, 3 pair, 6 electrons. But you should know double bond, 1 pi electron, or 1 pi bond, 1 sigma bond, triple bond, 2 pi bonds, 1 sigma bond. Now, for nomenclature, you name the longest chain as an alkane, the ane ending, you drop the ane ending, replace it with ene. For acyclic, that means not in a ring, you need a number. What carbon is the of the 2 carbon atoms in the double bond is closest to the end of the chain, and you need cis and trans. If it's acyclic and it's the only functional group in a ring, which in this class it will be, it's always going to be cis, so you can't have cis or trans. I think years ago, I saw a ring with 18 carbons. Somebody did in a paper that had a trans, but it's rare. Like, I haven't seen it since. So that's why we don't put cis or trans for rings, cycloalkanes. One thing I should mention, so I will, common mistake on test 1. First, I'll show you the right way. What's the name of this? Ooh, a ring. How many carbons in a ring? Count the bends. There's 6 of them. 6 is hexane. And because it's a ring, you need cyclohexane. And then one substituent is N-propyl. You don't need a number. So that'd be N-propyl cyclohexane. The mistake students make, and I had one student lose 10 points because she forgot to do this years ago. She would write this. Unfortunately, it's wrong because she forgot to put the cyclo. For a ring, you need cyclo. Cyclohexane, 5-carbon cyclopentane, 4-carbon cyclobutane, 3-carbon cyclopropane. So don't forget, when you're naming a ring, use the cyclo. Now, for a double bond, we have what's known as cis and trans. Cis is same side, trans is opposite side. And what do we mean by that? Now, if we look at these two molecules, and I'll call this one cleverly A and this one cleverly B. And the first thing you should be doing now when you look at an organic molecule, look for what's different. What's not a carbon-carbon single bond or carbon or hydrogen atom should get your attention like that. Hopefully that came through the microphone. Sometimes they filter loud noises out on Zoom. And so I have a double bond. How many carbons in the longest chain with double bond? Even though I'm showing the 120-degree bond angle, 1, 2, 3, 4, 5. They're all connected together. And 5 is pentane, but it's a double bond. Drop the A on E, replace it with E on E, pentene. What's the carbon closest to the end of the chain of the double bond? And we start from this side. You have 2, this one, or 3. And hopefully all know 2 is less than 3. So this would be 2-pentene. And then if we had a plane going here in the blue line, notice you look on each carbon of the double bond. If you have the same atom or group on the same side of that plane, notice underneath the line, the 2 hydrogens, that's cis. So this is cis 2-pentene. If you had other alkyl groups, you would number them, like if you had a methyl group on carbon 4 or whatever. Now, if we look at B, 1, 2, 3, 4, 5. 5 carbons is pentane. It's a double bond, pentene. Again, it's carbon 2. But now, that plane or line, or you can put your finger down or pencil, the hydrogens are on opposite side. And opposite is trans. So that would be, oops. Trans 2-pentene. So cis on the same side. This class will be mostly hydrogens. our secret. Okay. And opposite trans. And later in the semester, I think like about week 14 or a little later, I'll teach you how cis and trans double bond is how they came up with the name in fats and oils, cis fats and trans fats. All you have to do is look at a bag of potato chips and it'll say 0 trans fats. They're talking about a double bond. Are the hydrogens on the same or opposite side? Now, for a triple bond, since it's linear, there's no cis or trans, triple bond, 4 carbons, butene, butane. But you drop the ANE ending, put in YNE. Hold on, let me get this. Butane becomes butane because there's 1, 2, 3, 4 carbons. Notice if I start from this side, the lead carbon is 2. I do the other side 2. So this would be 2-butane. And that's how you do it. You don't have cis or trans. If I write down the name, you should know how to draw the structure. Time out for a public service announcement from the management, me, Dr. White. When you take test number 1, you'll download on Wednesday test number 1 PDF file from the assignment area of D2L. It will be password protected. Sometime 8 o'clock, or maybe if I get up earlier, I will send out an email with the password for test number 1 PDF file. You'll open it up. You can print it if you have a printer. If you don't, relax and take up to a couple hours to take test number 1. And then you'll upload it as a PDF file to the assignment area. I think you'll have until Thursday, 4 p.m. What happens if your internet goes out? I hope it doesn't, but that's why I give a long window. In the past, I know some instructors, they have different products that you can use that time a student, all that. And if their internet goes or they lose power like in a thunderstorm, what do? Well, that's why I do it this way. Now, as I've done with the labs, you have instructions. If you don't have, like I have my printer there, if you don't have a printer, you can just hand write out your answers. You don't have to hand write out the questions, but put for answer 1, number 1, so I know it's 1A and all that. And then if you don't have a scanner, you can take a cell phone. And I think this is for everybody of my students have cell phones or have someone they know they can borrow their cell phone. And you take pictures of it and you can upload that as a PDF file. I give one way. The easy way I found out from a student years ago was the app Cam Scammer. If you're going to use that, don't spend any money. You don't need to get all the bells and whistles that app will sell you. Use the free version. And that way you can upload it. If you have any questions while you're taking the test, on Wednesday, every 2 hours, I'll check my email. Wednesday night, I'll have my office hour and come by and ask questions. As I said, there's no such thing as a dumb question in my class. That includes while you're taking a test. Now, you can ask a question, what's the answer to this problem? And I'll say the answer is you got to figure that out on your own. But if you're unsure of a question, what is it asking you to do? Ask questions. All right, let's get back to the review. Oh, one other thing before we get back to the review. Every question on my test, I've covered the concept behind that question at least twice, probably a lot more, 5, 6, or 7 times. All right, now we started getting into the good stuff, and those are general reactions. And the first one is hydrogenation. I'll never ask the name of anything, but these are reactions you should know. And here, the first one is take hydrogen, a double bond, and a catalyst. The catalyst can be nickel, platinum, or palladium. You break the pi bond, and each carbon of the double bond gets a hydrogen. And that's hydrogenation. And hopefully you did the practice problems for alkenes and alkynes. However, let me show you something important. And say, so Wednesday, you see on a piece of paper this, 3 points each, give the organic product or products for the following. Well, what do? Well, you look at the molecule and say, what's different? What's not carbon? What's not hydrogen? What's not a carbon-carbon single bond? You should get your attention like that. And I see a double bond. The rest are carbon, hydrogen, carbon-carbon single bonds. Boring. And you're reacting with hydrogen. And here we have nickel, which is a catalyst. And hopefully you've memorized this by writing it down 5 times. Hint. And if you have a double bond hydrogen catalyst, you break the pi bond. Remember, it's 1 pi bond, 1 sigma bond. And each carbon of the double bond gets a hydrogen. Now, if you've been watching my videos, you've been hearing me say this a lot. You break carbon-carbon single bonds? No. And once I started brainwashing my students after the second semester, even the first semester I taught this, scores went up. So I have 1, 2, 3, 4 bonds, carbons there. I better end up with 4 carbons. Here are my 2 carbons of the double bond. I break the pi bond, and my general reaction tells me each one gets a hydrogen. I know there are 4 bonds to carbon, so I can put in the rest of the hydrogens. Now, on my test, you can leave it like this. Some instructors get picky and say, no, you got to write it with the hydrogens all in the carbons. Like you could have also written it this way. And you don't have to put the lines in there. I do that to make sure I keep my structure straight, because otherwise they droop toward the floor, which is not pretty. And that's how you do it. So either one of these would be correct on a test. This is just less work for you to do. Remember, do you break carbon-carbon single bonds except for combustion? No, not in my class. If you do, it's going to be wrong. The other bonds I'll teach you about, yes, you can break. All right, now if you take a double bond and react it with halogen gas X2, remember halogen is abbreviated in organic chemistry by the letter X. So X can be fluorine, chlorine, bromine, or iodine. Reacted with a double bond, you break the pi bond, and each carbon gets a halogen. You break carbon-carbon single bonds? No. So let's try one. And I'll let you try this because I'm going to share the fun tonight. Am I nice or what? Don't answer that. Have you gotten used to my sense of humor on my videos, both good and bad? And when you're done, give me a thumbs up. For next review, I'll have the polling in place. I forgot to do it for this one. You've seen the videos, you've seen where I've asked students, are you done? I do the polling, but anyways. Well, it looks like everybody's done. And how do you do this? Again, here it would say also give the products or organic product or products are the following. Well, first you look for what's different. What's not a carbon-carbon single bond, carbon-hydrogen atom. Ooh, a double bond. And we're reacting with bromine gas. Bromine is a halogen. Remember, X can be fluorine, chlorine, bromine, or iodine. By the way, some of my best students on their tests always write the general reaction underneath. Some of my best students never do. That was when we were face-to-face or on Zoom. Either way, you have to learn double bond, halogen gas. Remember, there's one pi bond, one sigma bond. I'll break the pi bond, and each carbon of the double bond gets a halogen. Do you break carbon-carbon single bonds? No. So I have 3 across and a methyl group. Here are my 2 carbons of the double bond. I broke the pi bond, so that's why there's only one line here. And each one gets a halogen. In this case, it's bromine. And bromine counts as a single bond. So I can put it in the hydrogens because I know there are 4 bonds to carbon. And the center carbon right here already has 4 bonds to it. And that's how you do it. Everybody through checking their answers? Now, so far, I talked about symmetrical addition of double bonds, stuff to double bonds. When you're adding something unsymmetrical, like HX, you break the pi bond, one carbon gets H, the other gets X. In this case, X is chlorine, bromine, or iodine. You don't ever want to deal with HF. That's the only thing in all my career I ever refused to work on a project dealing with that. That was years ago. And they got someone else, and that guy actually had a nervous breakdown because HF is so dangerous to work with. Project didn't work out anyways. And let me do this one. What would be the organic product or products of the following reaction? And I could ask this on a test. And what do? You look for what's different. Ooh, a double bond. What's not carbon? What's not a hydrogen? What's not a carbon-carbon single bond? Should get your attention like that. Hold on one second. Let me know. Give me a thumbs up. Can you hear this? Did you hear that? I used that too. Last semester wasn't working with Zoom. Anyways, instead of clapping, I would do this, and it should get your attention like this. By the way, never let the little kid inside of you disappear. So we have a double bond. reacting with HCl. Remember, halogens, chlorine, fluorine, bromine, or iodine, X. X can, for this reaction, be chlorine, bromine, or iodine. And you break the pi bond, not the sigma. One carbon gets H, the other gets X, and it follows Markovnikov's rule. And Markovnikov's rule is a carbon double bond with the most hydrogens gets the hydrogen, and the other carbon gets the halogen. And back when I learned it, I can still remember it decades later, my instructor said, you know how to remember Markovnikov's rule? The rich get richer and the poor get poorer. And we're talking about hydrogens. And this carbon has two hydrogens. This has one. Which is the greater number? And time's up. Hopefully I'll pick two. So the hydrogen will go to the end carbon. The other carbon gets the halogen. Do you break carbon-carbon single bonds? No. So I have 4 carbons. Here are my 2 carbons, the double bond. This one gets the hydrogen because it had the most hydrogens of the 2 carbons double bond. The other gets the halogen, which in this case is chlorine. And you know there are 4 bonds to carbon. And that's your product. Now, when you have a double bond, you can add H plus, which is the way organic chemists and most chemists in general put an acid catalyst and water. And you should remember for organic chemistry in this reaction, water is really H and OH. And you break the pi bond, one carbon gets H, the other gets OH, and it follows Markovnikov's rule. And let me do this one for you. Ooh, I can use this too. I have 4 of these. These were made by a company in Germany, West Germany, that's been out of business for years. They never leave my house. They're so valuable now to me. Anyways, look for what's different. Ooh, a double bond. We're reacting with H plus, acid catalyst, water. Remember, water is really H, OH. And you have a pi bond and a sigma bond. You break the pi bond, and one carbon gets H, the other gets the OH from water, also known as hydroxyl group. And this follows Markovnikov's rule. When I first started teaching, I used to try and write out Markovnikov's rule. I invariably spell it wrong, and I finally realized why waste time figuring out how to spell his name right and just abbreviate. So I do. But I still honor his great work, which is why I use his name and why we named it after him. So I have 4 carbons. Do you break carbon-carbon single bonds? No. I'll end up with 4 carbons, but I will break that pi bond, and one carbon gets H, the other gets the hydroxyl group OH. How do we know? Markovnikov's rule. The carbon with the most hydrogens on the carbons of the double bond gets the H, the other gets, in this case, OH. Well, this has 2 hydrogens, which is more than 1. And that carbon will get the hydrogen, the other carbon gets the OH group, and these each count as 1 bond. I know there are 4 bonds to carbon, and I can put in the rest of the hydrogens. And that's Markovnikov's rule. Now for triple bond, you have 2 pi bonds and 1 sigma bond. And pi bonds you can break like that, and I have. Actually, I did a lot of research when I started in the chemical industry, working with hydrogenation. And here, since you need more hydrogens, and organic chemists are lazy, we are, and I don't want to balance it, I use the letters XS, and that stands for excess. And that tells me I have as much hydrogen as I need to react with anything that hydrogen has that will react with. And you have 2 pi bonds, you break them, and each carbon now gets 2 hydrogens. And you don't break carbon-carbon single bonds. Now, for a triple bond reacting with halogen gas, same thing. I don't want to balance it, so I'm going to put the letters XS, and that means excess. I have as much, in this case, halogen gas that will react with anything halogen gas will react with. And again, 2 pi bonds. When you break each pi bond, each carbon of the triple bond gets a halogen. 2 pi bonds, each carbon gets 2 halogens. Do you break carbon-carbon single bonds? No. All right, let's go on to aromatic compounds. And I'm not going to ask you about Kekule's dream, snake dream on a test ever. But it's still interesting to think about how he came up with that in a dream. But anyways, here's benzene. And aromatic compounds are very stable because the double bonds that are conjugated, meaning alternating single, double, single, double, single, double, which I'll never ask you what conjugated is, are holding hands. And I showed that in the lecture, and that makes it very stable. Now, benzene is as here, and IUPAC, in their infinite wisdom, instead of calling it cyclohexatriene, that's never the right name, well, these chemists have been calling this benzene for centuries. We're not going to change their ways. We'll call it. Same thing with a methyl group on benzene. We're not going to change their ways. We'll call it toluene. If you follow, listen to the video, which I hope you have, listen to the videos. You learned about a cousin of my mother was a painter, and paint used to have benzene and toluene in it in the 40s and 50s, 1940s and 50s. And that's a very dangerous substance, and it rots out your organs and brains. And by the time I met him, when I was 5 or 6, he was about 1 step above a vegetable, which was very sad. But something I do want to talk about, so you don't make a mistake. Draw the structure for benzene. If you draw this, I can give you 0 points. That's cyclohexane. Remember, benzene has 3 double bonds in it. You can draw it this way or this way, which is another resin structure. Or the first 2, I think, are the cooler ways. That's the way I do it always, my examples. But it's perfectly correct on my test to use the circle to show the pi bonds in the benzene ring. Remember, this is cyclohexane. This is benzene. Whether in the name or reaction, if you have a product with a benzene ring and you don't show the bonds here, like this, sorry about the bad arrow, hold on. If you draw it like this, it's wrong. And I had a student lose 10 points on her page. Oh, she was upset. Oh, was she upset? because she didn't put the double bonds in there as a circle. So be careful. She did all right. She still got her A. She learned her lesson though. Be careful. What you draw matters. Now, I introduced new substituents. Cl chlorine is called the chloro group. F is a fluoro, Br bromo, I iodo, NO2 nitro. Then I talked about disubstitute the old way, which people still use. You should know when you have a 1,2 disubstituted benzene ring, that's ortho. Or toluene, the methyl group is considered one of the substituents. 1,4 is meta, or 1,3 is meta, 1,4 is para. And I'll let you try what's the IUPAC name for that molecule, 3 points each. And let me draw it again. I'm having a bad, I have bad hair days. Sometimes you have bad ring drawing days. That's a better looking ring today. Yeah. And your turn. Give the IUPAC name for the following. I'd like to thank everybody for turning on your webcams. And when you're done, give me a thumbs up. All right, everybody done? All right, we have, a benzene ring. So that's the root name. I have an ethyl group and a nitro group. Now, since I'm not holding you to the alphabetical rules, don't tell the IUPAC police, you could have put down nitro ethyl as opposed to ethyl nitro, but I followed IUPAC. If I call this 1, 2, 3, it's 1, 3, and that's meta. If it was 1, 2, that'd be ortho, 1, 4, para. And that's how you do it. Ooh, I'm on this. Let's do one more. Hold on. I'll wait until you're through copying down. Go back and look at the problem set answers in D2L, and you'll see examples how to do this stuff. In case you missed this in a lecture, you don't have to write this down. What's this called? Paramedic. 1, 4, paramedic. Who said organic chemistry can't be fun? Now, when it comes to reactions of organic molecules or aromatic compounds, you don't break the double bonds because then you'll lose the stability. So in the first reaction, you take halogen gas, and in real life, you're only going to use chlorine and bromine. I've never seen anybody do anything else. And you need for an aromatic compound halogenation, the catalyst ferric trihalide. This is called electrophilic aromatic substitution. Replace one of the hydrogens on the benzene ring with a halogen. And there are only two reactions I can ask you, with X being chlorine or bromine. Now, as I mentioned in the lectures, when there's something on the ring, you can have different directors, and you'll be doing a lab with this next week, but I'm not going to teach that in this class because I'd rather spend more time on things later in the semester that you might find useful the rest of your life, like learning about fats and oils, carbohydrates, proteins, and something really interesting, how soap works. I'll be teaching you that. Ooh, coming attractions. But anyways, so that's that. Now, if you take benzene ring and react it with nitric acid, HNO3, and sulfuric acid, H2SO4, you'll put a nitro group on the benzene ring. And this is the only reaction I can ask you on the test because I'm not going to ask you to learn directors. But remember, this is NO2, common mistake, students put NO3. And guess what? I mark it wrong. A nitro group is NO2. Now, if you take sulfur trioxide and sulfuric acid, H2SO4, react it with benzene, you'll put on a sulfonic acid group. I didn't ask you to learn that name, but I'll use it later on because by having sulfonic acid group on a benzene ring, we can make the key molecule that's used in your laundry detergent, whether you use all, Cheer, or another brand. Part of the molecule that gets your clothes clean is made by sulfonation of a benzene ring. How about that? And finally, my favorite, Friedel-Crafts alkylation, where you take a benzene ring, react with alkyl halide. R is like in math, X and Y numbers. R is anything with carbon and hydrogens that has a halogen, aluminum trihalide. You replace the hydrogen with the R group, and R is the carbon in R with the halogen is the carbon bonded to the ring. So let's go through and try one of these. And the question would be, what's the product or products, organic products, of the following reaction? In case you haven't gotten to this reaction yet, I'll help you out. On test, I won't, but now I will. And when you're done, give me a thumbs up. Or if you want, you can do a thumbs down. I don't know, has anybody ever done, oh, that's called hitchhiking, so don't do a thumbs horizontal. Oh, it's bad humor Monday night, sorry. All right, let's do this. What do I have that's different? Benzene ring, carbon, carbon, carbon. Ooh, halogen on a carbon, that's an alkyl halide. This is my R group. And my general reaction shows me benzene ring, alkyl halide, and I have aluminum trichloride, aluminum trihalide. I put an R group, Friedel-Crafts alkylation. So first of all, I'm going to have my benzene ring. Don't forget to put the double bonds or a circle. Then my R group, 4 carbons. Do you break carbon, carbon, single bonds? No. And which carbon has the halogen? The N carbon. So running out of room here, I'll rewrite this. Can I write this any smaller so you can't see it? Of course. And that would be it. Now, if you'd written this down, which that student did, who lost a lot of points, this is wrong because this is cyclohexane ring. This is a benzene ring. That's right. Remember that. All right, let's go through a few more things that I wanted to cover that I talked about. And you should know what would be the product or products of this problem, this reaction. Now, if we look at the molecule, what's different? I'll give you 5.2 seconds to look and find what's different. 4.5, 4 3/4. Time's up. Oh, look, I have a double bond here, but I have a double bond here. And that's a diene, two double bonds. I talked about in the lectures, if you have two double bonds, they're separated by more than one carbon, one or more carbons, and notice this is separated. Each one is independent. And what do we have? A double bond, Cl2, halogen gas. X can be fluorine, chlorine, bromine, or iodine. And you break the pi bond, and each carbon gets a halogen. But we got two double bonds, so we need more chlorine, which is why I put the excess there. That tells you got all the halogen in the world you need. So, do you break carbon-carbon single bonds? No. I have 1, 2, 3, 4, 5, 6, 7 carbons. I better end up with 7 carbons. Which carbons are the carbons of the double bond? These two right here, and these two right here. And our general reaction says each one gets a halogen. And what's the halogen? Oops, wrong color. Come on, change. Chlorine. So each one of those will get a halogen. And I know there are 4 bonds to carbon. And there we go. So when you have more than one double bond or functional group in a molecule, they're separated by more than one or more carbons, they react like they're alone, which is what this happened. Now, on test number 1, I will have what's called one synthesis problem, where you have to give the starting material. And the question would be, also known as the reactants, and the question mark tells you there's one starting material. Oh, how do you do that? Now, this is a much harder problem, which is why I'm only putting one on the test. And how do you do that? You look at the product. What are you making? And you look for what's different. What's not a carbon? What's not a hydrogen? What's not a carbon-carbon single bond? Should get your attention like that. Ooh, it works today. And I have a chlorine. So I have a carbon with a halogen. And an adjacent carbon, I have a hydrogen. Now, this one, I made a mistake. Everybody, I apologize. Let me rewrite this molecule. I apologize. On the tests, I make sure I don't make these kind of mistakes. All right. Still same thing. What's different? A halogen and an adjacent carbon, a hydrogen. Now, why did I write this? Because I'm reacting something with HX, where X can be chlorine, bromine, or iodine. And remember, this follows Markovnikov's rule. And what do we start with? A double bond. Now, if we look at this and use logic, by the way, this is what makes organic chemistry interesting and some people hard. The carbon with the halogen is one of the carbons of the double bond, your starting material. Carbon with the hydrogen that's attached to the carbon with the halogen is the other carbon. Now, do you break carbon-carbon single bonds? Except for burning it, combustion? No. So I end up with 4 across. I better start with 4 across. On this carbon, I have 2 methyl groups. They better be there. So they have to be there where you start. The 2 carbons that I'm interested in, whoops, come on, change color on me. This carbon is this carbon, and the only adjacent a carbon with a hydrogen, adjacent means attached to the carbon with the halogen, is this carbon. And that's the other carbon double bond, which means these 2 carbons. So there has to be a double bond there. And now I know there are 4 bonds to carbon. And I can put in my hydrogens. And that's the answer. Now, someone might say, why not have the double bond also to that carbon? Well, let's look at something. And that would be this. I'm not going to even put in the hydrogens. Does anybody see something really wrong? I see someone does. How many bonds to carbon? 4. If you look at this carbon, it has 1, 2, 3, 4, 5. Wrong. It can't happen. So remember, when you're writing a structure, make sure you have 4 bonds to carbon. If you have 5 bonds, guess what? It's wrong. In fact, it's so wrong, my eyes tell my hand to mark it wrong. It doesn't even have to go through my brain. No, I'm just kidding. But it's like that. Oh, I once had a student had a structure with 6 bonds to carbon. It took me a couple minutes to stop laughing. It was still wrong. So Remember, there's going to be one synthesis, and you use your general reaction to help you go backwards to the right structure. And your friend will always be, do you break carbon-carbon single bonds? No. And with that, I'm done. Except, first of all, I ask, does anybody have any questions whatsoever? But the only one I haven't figured out, what's the meaning of life, but anything else I could probably answer. All right, let me ask a personal question, and you don't have to answer it if you don't want to. Was this helpful?
Yes. Dr. White, I have a question. When you told us to draw the structure for cyclohexane, do you want us to do like count the curves, like do you want us to label it with
Are you talking about cyclohexane or benzene?
cyclohexane?
All right, let's go back and then I'll ask again, everybody. All right, when you have a cycloalkane, every bend in a line is a carbon. Now for this class, the only ones you have to know, and it's the only ones I've ever seen in the chemical industry on a common basis, is six benz, that's cyclohexane. Six is hexane, it's a ring, cyclohexane. 5 carbons is cyclopentane. For those of you who played Monopoly, doesn't that look like the little greenhouse? By the way, I think I told in the video, when I was young and my older sister was 7 years older than I, and we both would get sick and stay home from school with the colds or whatever, we'd play Monopoly and we cheated. Whoever went to the bathroom, the other one stole $500 bills from the bank. We played cutthroat Monopoly. Now, 4 bens, you call that a square, I call that a ring. 4 is butane. So that would be cyclobutane. And finally, 3, you call that a triangle. I call that 3 carbons, propane. Now you can have 7, 8, 9, 10, and onward, but in real life, you don't really encounter that. Oh, I have you here. First of all, I'll let you write that down. If you're writing it down, you can, everybody got that down who want to write it down? Okay. This you don't have to write. This is cyclo, and you don't have to write this down. I'll never ask on a test. Cyclooctane, and every time I come to a stop sign, I think of cyclooctane. But in real life, I've never used that or encountered it when I've worked for, I don't know how many decades in the chemical industry. It's just that rare. All right, any other questions? Remember, you can always ask questions. Come to my office hour. If you can't make it to my office hour and you need help with anything, including the labs, email me, and if I can, we'll come together. We'll set up a time for a private Zoom meeting because I want students to do well. Do the practice problems again before Wednesday. And since it's due Thursday afternoon, you could even do it Wednesday night and still go back and take tests on Thursday morning, as long as you get it uploaded by 4 p.m. So with that, I'm done for today. Wow, I went pretty good. Hopefully it was helpful to you. I hope you all do well. And I'm done. Anybody have any last minute questions or anything?
Thank you.
Thank you for coming. Kein gesund. Goodbye.
Hi.